Hello, Hashi Sensei, how are you?
Thank you very much. So, good afternoon, so Professor Tawahida. Can you hear me?
Yeah, I can hear you, and I think all of you are hearing you. So, how is your health now?
Yeah, very well, thank you.
Okay, thank you.
I'm now in Japan. Japan is somewhat cold.
Yeah, I heard about it. Yes. So, I mean, is there any plan to visit Dhaka shortly?
I'm very sorry. So, I told you the last visit I will come to Bangladesh in this December, but in these times I cannot prepare the I cannot make the preparation. So, but I will come to Dhaka again in the end of January.
Oh, January. Okay.
So, and I will stay about 20 days, and that is a JICA project.
Okay.
Same as the visit in last September.
Last September, yes, I had. Understand.
And I'm planning to visit again.
So, okay, thank you. It has been nice meeting with you. Yes, thank you. Okay, stay healthy. Okay, I think session will be started soon. Thank you.
Can I make sure the presentator's name, and the first one is Dr. Kamimera-san?
Professor.
Shubhu is conducting the session. Yeah, thank you.
Okay.
So, Professor, thank you for being present at the session. So, before you just begin, I'll just briefly introduce you and also the Honorable Session Co-Chair to the presenters. So, this session is technical session 4, nature-based climate solutions, and we already have Professor Dr. Taichi Hayashi from Kyoto University, Japan. And we also have Dr. Mohan Kumar Das from Noami, Bangladesh, since yesterday, actually. So thank you again for joining us, and thank you for being with us throughout this conference. So with that note, I'll leave it to you for moderating the session. Thank you from our side. Professor, you can begin.
Okay, thank you very much. So thank you very much for all the participants to join this session. My name is Taichi Hayashi of Kyoto University. I will have I will chair this session of nature-based climate solutions, and first part. So we will start the presentation. The first presentation is by Dr. Hideyuki Kamimera in Japan. Please start the presentation.
Okay, thank you very much, Professor Hayashi. Can I share my screen? Can you see my screen now?
Yeah, it is perfect.
Okay.
So could you please go to first slide? Yeah. Okay, fine. Perfect.
Okay. So my title of my talk is Intercomparison and Hydrological Validation of Satellite-Based Rainfall Estimates over the Meghna River Basin. And I am a Kamimera, and co-authors are Islam Kairul-san, Dr. Islam Kairul-san from the Bangladesh Water Development Board, and Mohamed Rasmi-san from the International Center for Water Hazard and Risk Management, and Fumie Murata-san from Kochi University. Thank you very much for providing us this very nice, good opportunity to talk about our research. So the purpose of this study is very simple. it is to examine the performance of the satellite-based rainfall estimates over the Meghna River basin. And how to say, just a moment. Okay. This map showing the Meghna River basin, and the yellow line shows the national borders, and the green line, no, green line shows a boundary of the basin, and the light blue line shows rivers. And there are two stations for the hydrology, and at Amarsit and Baira Bazar. And in this study, the basin is divided into 4 sub-regions: Barak, Meghalaya, Tripura, and Sylhet. And aerial contribution ratios of the Barak, Meghalaya, Tripura, Sylhet regions are 13, about 40%, 18%, 11%, and 30%, respectively, as a percentage of the entire Meghna River basin. And about 70% of the basin belongs to the India or Myanmar. And the remaining area of about 30% is in the downstream country, Bangladesh. Okay, so then what we do in this study? This study first compares 5 products of satellite-based rainfall estimates for 4 subregions of the basin. For the 8-year period from 2009 to 2016, or only for the trim product, 16-year period. And long-term total volume of river flow and total amounts of rainfall over the catchments are also compared at the 2 locations, Amarsit and Baira Bazar, for hydrological validation. And this is results for the comparing mean annual rainfall and river flow. Through this intercomparison, it is demonstrated that there is a significant variance between mean annual rainfall estimates, particularly over the Meghalaya region here. And the area of the Meghalaya region is 18% as a percentage of the basin. However, the total amount of rainfall over the region ranges from 21% to 37% as a percentage of rainfall amount over the entire basin. As shown here, this clear uncertainty in the rainfall estimates over the Meghalaya region cannot be ignored for the better management of water-related disasters or water resources, particularly in the downstream country, Bangladesh. So it is very important. And variances between rainfall estimates can be seen from such intercomparisons, but true values of rainfall are still unknown. Therefore, in this study, a long-term total volume of river flow and total amounts of rainfall over the catchments are also compared at 2 locations, Amarsit and Baira Bazar. Amarsit is located here, and Baira Bazar is here. And at Amarsit, the total volume of river flow is smaller than the total amounts of rainfall over the Barak region. in all the rainfall products. It is consistent with the situation that the component of river flow from the Barak River into Salma River is not included in the river flow estimates at Amalsit along the Kushiara River. And at the Baila Bazar, a total volume of river flow agrees with the total amounts of rainfall over the entire Megha River basin in the TRIM, PR, and GS map products. So through this kind of hydrological validation, rainfall estimates can be examined from the viewpoint on regional water balance. Okay, this kind of analysis is very important to assess the performance of the rainfall products. Okay, then this is very short summary for this research. This study has compared 5 products of satellite-based rainfall estimates for 4 sub-regions of the basin. And through the intercomparison, it has been demonstrated that there is a significant variance between mean annual rainfall estimates, particularly over the Meghalaya region. And this is a clear need to estimate rainfall more accurately and precisely over the basin. To meet such need, radar-based rainfall estimation can be applied as a viable solution. So I'm now doing another project for the BRAIN. BRAIN means borderless radar information networking over South and Southeast Asia. Not only this region, but also any other neighboring regions. I am doing similar work. And for Meghna region, there are many existing weather radars, not only in the Bangladesh, but also neighboring India or Myanmar. So we can utilize these radars for the estimation of rainfall in the coverage of radars like this. For example, this is the climatological map of the observation of Cherrapunji radar located in the Meghalaya state, India. And this is an example of the radar echo animation from the BMD radar. And this is an example of the animation of radar echo from the Myanmar radars. So by using these radars, we can estimate rainfall, I think. So one good example already have been done in Cambodia, not in India or Bangladesh, but this is, I think, good practice for application in Bangladesh or India. By using both weather radar data and rain gauge data in the coverage of the radar, we can combine to estimate rainfall like this. So in this case, the results is very much good for the estimation of rainfall. Okay, this is my the end of my presentation. Thank you very much. Donovat.
Thank you very much, Dr. Kamimera. Are there any question or comments? to the this presentation.
So, may I ask one small questions to Hideki Kanimera?
Hi.
Yeah, so it's a very nice presentation. So you started to compare 5 products. One is TRMM, and another charts and GSMF, finally another 2. So as per your special distribution, it shows that TRMM showing a bit intense rainfall, but GSMF showing underestimation, if I am not wrong. So, and MSWP showing some white border, maybe it is the high terrain, which is not perfectly covered. So, and another thing is that maybe there is a very less station observations. So you are not able to compare some data with that. But in the next part, you just compare with the, you just try to get one initiative with the radar. So the thing is that why MSWP not showing some rainfall about the regions, and why GSMAP is showing so underestimation? What is your opinion, please?
Okay. At first, for the MSWEP, as shown here, so white color means very much high rainfall over the Meghalaya region, more than red color. So, and in GSMAP product, yeah, as told you, as you mentioned, okay, yeah, rainfall is very much less than others. So I'm not sure why, but maybe, how to say, basically GSMAP products are based on the microwave satellite observations. So, and how to say, but and number of how to say how to say frequency of the observation of microwave sensors are not so high in this region. So therefore, sometimes microwave sensors cannot capture the convective activities over this region, I think. So, but yeah, anyway, for that, we need more studies in this region to correctly explain about the region of the GSMAP product.
Yes, it is all right, because the thing is that, of course, you compare 5 products, so some products result may not be that much up to the mark. And another is the Aphrodite. I think that product is somehow has very good agreement with the station observation data. So I'm not sure why you not consider those data set here. Maybe 2015 onwards data is not available. That may be one reason, or I don't know. Please.
No.
Are you familiar with the Aphrodite data?
I know, but I haven't yet checked the performance of the Aphrodite data in this region, because this is our first step to evaluate satellite rainfall products only. So in the next step, we will assess the gauge-based rainfall products also in this region. Yeah, thank you very much for the good suggestion.
Okay, thank you. Thank you. So, Honorable Chair, I think we can request our distinguished participants, if they have any comments or any questions, please come forward and ask, because we have little time to take 1 or 2 questions from the audience. This is really an interesting study.
Thank you very much.
Thank you very much, Dr. Kamimera. So it's time to move to the next presentation. Thank you, Kamimera-san.
Thank you very much.
Next presentation is Dr. Abahawa Bigyan Bivag.
Yeah.
So
Good morning, everyone. So I'm here. Just I take 30 seconds, maybe 20 seconds to prepare to put the slide on, right? So I am here available, and it is nice to maintain time. Thank you. So can you just see the slide now?
Not yet, sir.
Okay. Is it okay?
Yes, it is here. We can see.
Okay, full screen, right?
Perfect.
Okay, thank you very much. So I will take the stipulated time, whatever you have given. So hopefully I will not overshoot. My topic is, research topic was, traditional weather climate knowledge of farmers in Bangladesh, a need for strengthening agro-meteorological advisory services. So very particular subject at this moment of climate change, I believe. And as you know, I am Dr. Mahbub Jahan Khan, basically founding chairman of Mars Limited. It is a private weather service company in Bangladesh, the only and the first private weather service company. And I was also director of meteorology of Bangladesh Air Force for around 6 years, and I served 27 years in Bangladesh Air Force. And primarily, I am an agriculturist by education and a meteorologist by profession. I had some learning from India also in Coimbatore. So, respected chair of the International Conference on Climate Change, dear moderator, distinguished scientists from home and abroad present at the seminar venue and connected online. A very good morning from Bangladesh. So I would like to beg apology first for not being able to present physically for some obvious reason. And I shall take around 10 minutes or 11 minutes time to present my paper. Then I shall remain standby for answering your query. So the sequence I shall be following, you can see on the screen for today's presentation: background of the study, brief literature review, problem statement, objectives of study, methodology, limitations of the study, major findings, recommendations, and question answer session. Due to paucity of time, I will skip some of the slides as I require. And the first slide, you can see a gentleman whom I interviewed just recently as a farmer. He is from northern Bangladesh. Now, regarding vulnerability of our crop production to weather, I would like to bring some point. Most of you know that flash flood damages our crop mostly in the northeastern region. Okay, our region, the weather occurs over our upstream, then it comes down to our area and it damages huge crop in the country. Then it is the question of drought, which occurs mostly in the northern region. And then it is the question of cyclone, very frequently visited country. Okay, at least 2 to 3 cyclones visits Bangladesh in a year. But threatens, maybe more number of cyclone threatens us. Some passes through some coast of India. It is there a common weather phenomena. Then it is the hailstorm, which damages our crop, even vegetables. Then heavy rain for a couple of days. If the rain persists, then it makes the harvesting difficult and it damages our crop. So I have some very important realities. I brought out 5 major realities here. First of one is, as I said, Bangladesh is a weather-prone country. Second one is, I would like to say that we have maintained a climate unsmart agriculture till now, but we are improving. That is fine because the government initiative, we are going ahead, moving forward, but still we maintain a climate unsmart agriculture. Agro-meteorological advisory services is just growing. It is a growing field. and it is getting momentum in this country. Farmers' weather awareness is inadequate, which I observed, and the climate itself is changing. So things are getting really difficult to forecast. At the same time, probably realizing this importance, we have this seminar today or conference today on climate change. Now, with this, I have some literature review over here, but I will not really present them in details. You can see, different scientists have some findings that, farmers has got some traditional knowledge on weather. They predict weather, and they live on the whim of, weather and climate, and whatever crop comes, that is their, production. Regarding problem statement, I can say this much, that weather plays an important role everywhere in the globe. Same is true in Bangladesh, and we suffer badly from extremities of weather and climate. Different stages of crop growth has different kind of weather requirement, which ultimately determines yields. Farmers are not fully aware of climatic factors like rainfall, temperature, wind, relative humidity, etc. They often depend on their traditional knowledge on weather and climate. There is need for studying the dependence of farmers on traditional knowledge on weather, climate, the state of agrometeorological advisory services in Bangladesh, the reach of the same to the farmers, and finally, how agromet specialized services can be made more effective for our toiling farmers in Bangladesh needs special attention. With this, I would like to switch over to the broad objective of the study. Basically, it is to explore the prevailing traditional knowledge of the farmers on weather and climate, and to see whether there is need for strengthening agrometeorological weather services for them. However, the specific objectives are studying farmers' existing knowledge on climate and weather, then identifying various natural indicators of weather and climate which farmers use, study the existing agrometeorological advisory weather services, whatever is available, see the reach of these services in Bangladesh, then ascertain the need for weather and climate services, and finally examine how best the weather climate need can be met. The methodology I followed is a very simple one, because it is a pilot study, what I am presenting before you, planned exhaustive research on the same topic. It will be conducted in 2023-24, inshallah. So 60 farmers were taken. They had been interviewed in face-to-face sitting and over cell phone. The sample was drawn taking 15 from each upajala. I have selected 4 upajala, sub-district. While selecting farmers, their minimum farming experience was 10 years or so that the inherentness of traditional knowledge is better revealed through the study. Of them, 75% were drawn with more than 20 years of farming experience. Independent variables like formal literacy, functional literacy, farming experience, ownership of farm, access to mass media, internet, and diversity of crop they grow, etc. were also studied to see their correlation with the farmers' traditional knowledge on weather and climate. However, no inference is drawn in this pilot since the sample size is small, and it will not be presented over here. Various sources of secondary data available in different journals, books, and other pertinent research studies in open sources were consulted. So naturally, my study has got some limitations. As I say, it was carried out in 4 upajala of Bangladesh. Basically, the name is Jinada Sadar Upajala, Koira Upajala of Satkira region in the southern Bangladesh, Barhatta of Netrakona, and Atpar of Netrakona. This is in northeastern Bangladesh or northern Bangladesh. Respondent farmers are predominantly rice growers. Some of them grows oil seeds and vegetables too. The convenient sampling was followed to complete the study, mostly over phone. This is primarily a pilot study, as I said, and which will be followed by exhaustive research in the coming years. Now, regarding the findings, I would touch upon some farmers' traditional knowledge on weather and climate. So, some of the farmers said that mound building of ants indicate rain is approaching. This is to be contested, verified through a scientific study, But whatever they have spoken, they have responded, I have just listed here. And marching together with eggs in their mouth indicates imminent rainfall. Migratory birds, especially the ducks of low-lying bills or haors or water bodies in Bangladesh, don't settle in water. So it indicates there might be rain again. Ring around moon, the local people said Chader Shoba or meeting of the moon. And there, within the ring, there remains some star also. If this is the situation, there might be rain. Croak of frog indicates more rain to come. Then, regarding wind, there are some findings. During rain, if wind becomes easterly, they will improve soon. In Shravan Bhadra, Bengali months of Shravan and Bhadra, southerly winds signifies more rain to occur. In Boishak Jeshta, the beginning of the year, darkness in the northwest brings Kalboishaki storm. Westerly wind in Chaitra indicates drought to occur. Easterly wind in Falgun is an indication of reverse stream in the river. They say river stream, actually river flows, but since the river swells up with a lot of rain or coming rain, so they consider that the stream is reversed. Actually, it doesn't happen. If no star is seen in Jyeshtha and Ashar, drought is likely. So regarding other findings, especially with the agro-meteorological advisory services, whatever is available with Bangladesh, as I said, it is a growing science and growing service. Bangladesh Met Department plays a leading role in agro-meteorological services through Farmers Bulletin and weekly and for fortnightly forecast, etc. Bangladesh Agro-Meteorological Information System, maintained by Director of Agriculture and Extension. So they have started new. Winmiyaki Limited used to provide this service and advisory service. I am not sure about their existence now, but 3 to 4 years back, they were really active. Bangladesh Agricultural Research Institute maintains an agromet division. Bangladesh Weather Observatory Team, BWOT, a team from Narail is working, but so far I know this is not maintained by professional weathermen. Different universities have opened agro-meteorological departments, especially in Bangabandhu Sheikh Mujibur Rahman Agriculture University at Gazipur and Bangladesh Agriculture University at Mymensingh. And we know that Bangladesh, Dhaka University also, this meteorological department is playing a very pioneering role with regards to research, and hopefully they will also complement to our weather advisory service. And our company, Mars Limited, is connected to this university also, by a very good connection. Then firstly, that is an app maintained by ACI and apps Khamari run by Bangladesh Agricultural Research Council. Flood forecasting and warning center, they give forecast on flood. Then on the other day, just this month, I read a newspaper that Botiaghata Khulna meteorologist, there is a group, they give forecast for 2 areas and they maintain an apps PIXA, that is participatory integrated climate services for agriculture. Then finally, it is the Mars Limited, an organization which I led. In fact, 6 of retired Bangladesh Air Force officers, all meteorologists, we started this company in 2015, and it is a registered company in 2017. And by now, we have achieved a lot of laurels. And this year, we have been recognized as the best agro-tech company in the country in 2022 by Channel I, a media partner, and electronic media, and also ICT division. This is jointly given by ICT division of the ICT Ministry and Channel I. So this month, in the month of March 2020, we received this recognition. We have some other findings, say about the reach of this agro-meteorological service to the end users level, farmers level. only 7% respondents received some kind of weather information from Bangladesh Met Department, but not regularly and mostly from indirect sources. I mean, in some cases it is a hearsay, sometimes it is from the television. 97 farmers say that they need weather service regularly to grow better crop. 10% respondents are ready to pay Bangladeshi taka 300 per year for the same. This was asked because we charge around 600 taka generally for the city dwellers and other customers, but not for the farmers. For farmers, it should be cheap because they will face difficulty in paying 600 taka per year also. 50% respondents are ready to pay Bangladeshi taka 100 per year for weather service. 40% farmers are not willing to pay any money, rather depend on the whims of nature. Experts say traditional knowledge of farmers better be coupled with scientific knowledge to benefit the most in terms of boosting the crop production. With this, I would like to bring some couple of recommendations for this house. And first one is, farmers' traditional knowledge may be verified with the scientific knowledge. There must be some, causal reason for which they are saying so, or they're having this kind of information or knowledge. Number two is crop-wise weather forecast requirement may be assessed because different part of the country grows different types of crop. So a generalized weather service will not work for them. Diverse forecast product may be devised to meet varied needs zone-wise. And free of cost agrometeorological services may be made available to the farmers. And finally, effectiveness of the agrometeorological services may be evaluated time to time. With this small little presentation, I would like to invite any question so that I can meet your query. Thank you very much.
Thank you very much, Dr. Dr. Khan. So, any other questions? Any questions or comments? Time is a very short question or comment, please. Okay, Professor Terao.
Yeah, I have one short question. So many traditional knowledge is very interesting, and so I like to introduce. And one thing I like to ask you the meaning of the westerly in Chaitra indicates some drought in some other verb or something. So what is the meaning? Chaitra, I don't know the Chaitra, so can you tell me what is Chaitra and what is the meaning of this?
Okay. So sorry for not really changing to English months. It is a Bengali month.
Yeah. So yes, it is some problem.
Yeah, it is the end of the Bengali year. So yeah, it goes with the March and April.
March or April, I see. So in this season, westerly means a drought signal.
Yeah.
I see. Yes, I understand. Yes, thank you very much. Yeah. Yes, very interesting. Yeah.
So it takes half the month of English month and next half of the another month. So that's why I did not change, because they responded in a Bengali one. Thank you very much. Sorry for the I should have addressed that one also. So seeing that I have some friends from outside. Thank you.
Also. Yeah, thank you very much.
Thank you very much, Dr. Khan. So it's time. Time is up. So we will move to the next speaker, the Abhijit Dasan, please.
Thank you everyone for patient hearing, and I would love to have some cooperation from everyone as I am switching over to an exhaustive study. Thank you once again. Assalamu alaikum.
I think, thank you. Honorable Chair, Mr. Abhijit Das may not present here. I think Mr. Shubho, could you please read his abstract? Oh, Abhijit, are you there?
Okay, sir, I can pause him.
No.
No, I don't
I think
see
there
it.
is a question. Shubho, there is a question from Tyagi sir. Is traditional knowledge validated beyond the short range? So I think we can take the question, right? Dr. Tyagi
Definitely,
sir,
sir.
could you please
Definitely.
ask the question? Yeah.
Yes,
ask the
Tiago-san is the present and the question. Is traditional knowledge valid beyond short range? Okay, so Dr. Khan, please check the chat and please.
Yes, sir. Please.
Yeah, thank you for a good presentation. The traditional knowledge, no doubt, is very important part, but we need to validate short range traditional knowledge. I fully vouch that yes, it does help. But when the agricultural operations mostly are dependent critically on the medium range and the extended range forecast, does the traditional knowledge provide some useful insight about these time scales? So if that is there, should be part of the study.
Thank you, sir. This is very important questions. Maybe unfortunately, the presenter is not available. I have not seen him. So if he joined, we will address the question to him again. Thank you, sir.
Oh, welcome.
Okay, sir. Yeah. Honorable Chairman, sir, please. Sensei, I think we can move forward to next presenter. Then we can request Mr. Shubho to read his abstract.
If he find Dr. Abhijit Dasan, so on the later presentation, okay. And the next presentation is Mohima Sultana Mimi.
Yes.
Yeah, please start the presentation. He's here.
Yeah, she's here.
Yeah, okay, she's here. Yeah.
Mohima, please. Yeah.
Good morning, everyone. Can you hear me?
Yes, Mohima. Yeah. Please share your slide and start your presentation, please. Your title is The Influence of Indian Ocean Dipole on the Variability of Mesoscale eddies in the Bay of Bengal. You're welcome. Yeah, your slide is visible, so please.
Can I start now?
Yes, perfect.
Good morning, everyone. My name is Mohima Sultana Mimi, and I'm currently working as a research associate at the International Center for Ocean Governance, Department of Oceanography, and University of Dhaka. Today, my presentation topic is the influence of Indian Ocean Dipole and El Nino Southern Oscillation on the variability of mesoscale eddies in the Bay of Bengal. In this presentation, I will try to cover these parts. First, the introduction and motivation part, and second part is about the data and methodology, and finally, I will show some key results from this research. So, first of all, what are mesoscale eddies? In general, eddies are circulating vortex which spin around a center, and the mesoscale term comes from the scaling of the ocean. If the oceanic eddies have temporal scales of weeks to months, and also the spatial range from tens to hundreds of kilometers, so that's why oceanic eddies are called the mesoscale eddies. From these two animation, we can see the propagation of mesoscale eddies in the Indian Ocean, and also some detected eddies from the satellite altimetry. So why mesoscale eddies are important? Because they have so much contribution not only in ARC interaction but also in transport of biogeochemical tracers. They transport large-scale water mass. Sorry, they contribute to large-scale water mass distribution, and also they regulate the regional and global climate. Also, they influence the sea surface temperature, heat flux, cloud cover, and also rainfall. They also transport vertical nutrient through upwelling and downwelling process. There are mainly two types of eddies based on rotation. Cyclonic eddies and anticyclonic eddies. And cyclonic eddies rotate counterclockwise, and they contribute to the upwelling process, and which helps to upwell the nutrient-rich water to the surface of the ocean. And overall, eddies are important for the ecological and economical sustainability of the coastal regions. And in this study, I've investigated mesoscale eddies in the Bay of Bengal, and their spatial and temporal variability, and also how the planetary waves as well as the climate variability influence the mesoscale eddies in the Bay of Bengal. So the next part is the data and methodology. This is the study area, the location of the study area. As you can see from the animation, that mesoscale eddies are generated in the eastern Bay of Bengal, and they propagate westward due to beta effect or the Rossby wave. And for the study, I have used satellite altimeter altimetry data, which is the sea level anomaly data, and I have detected mesoscale eddies from the sea level anomaly data from 1993 to 2021 for a 29-year period. For detecting the mesoscale eddies, I have from the satellite sea level anomaly data, I have detected mesoscale eddies. First, I identified the inner center of the eddy. If the center, if the value of the sea level anomaly is highest or local maximum value, it is identified as anticyclonic eddy. And if the value is minimum value of sea level anomaly is identified as cyclonic eddies. And after that, we iterate over the center, and when we find a contour, which is the perimeter of the eddy, satisfies some set of criteria, then it is identified as the eddy. After that, we move forward to the next time step, and by doing this process, we have identified eddies from the daily data sets around 1,000 days, and we result, and the dataset has been stored. And this is the results part of my study. During the study period, I have calculated the mean properties of the eddies, and this is the seasonal variability. And from the number of eddy generation locations, we can see that most of the eddies generate in the eastern Bay of Bengal, and they propagate toward the western Bay of Bengal and dissipate in the western Bay of Bengal. And the radius amplitude are comparatively higher in the western Bay of Bengal. And from the trajectory of the eddies, we can see that most of the eddies are clustered along the Andaman Nicobar Islands and Myanmar BAM, because the topography plays an important role for the formation of mesoscale eddies. And this is the main properties of eddies. In seasonal distribution and also annual, which is consistent with the mesoscale eddy trajectory atlas dataset. And finally, I did a comparison of properties of mesoscale eddies with the climate variability with the wavelet analysis. Wavelet analysis is kind of a coherence or correlation, and here 0 to 1 means the correlation scale. And from this wavelet analysis, we can see that the properties of anticyclonic eddies correlate strongly with both ENSO and IOD. So from this analysis, we can say that the anticyclonic eddies are affected by both ENSO and IOD compared to cyclonic eddies. And also the remote process which influence the eddy formation in the Bay of Bengal, when the equatorial zonal wind and equatorial coastal Kelvin waves propagate through the equator, and they split in the eastern part of the Indian Ocean near the Sumatra, and split into two parts. And one part propagate toward the coastal perimeter of the Bay of Bengal, which is the coastal Kelvin waves, and there are four coastal Kelvin waves. Two is upwelling and two is downwelling. Toward the upwelling and toward downwelling. The first upwelling coastal Kelvin waves arrives in January, February, March, and after that, first downwelling, and then again first upwelling, and the strongest coastal Kelvin wave is the second downwelling coastal Kelvin wave, which arrive in October, November, December, and which propagate to around the perimeter of the Bay of Bengal and can reach up to the Arabian eastern part of the Arabian Sea. This is the normal mechanism of the coastal Kelvin waves during normal neutral years, but when the IOD or positive IOD or El Nino occurs, the total pattern changes. The second downwelling coastal Kelvin wave becomes totally absent. Instead of it, during the October, November, December, there is upwelling is observed in the Bay of Bengal, which has a severe impact on the formation of eddies in the Bay of Bengal, as the coastal Kelvin wave is the primary generation mechanism of mesoscale eddies in the Bay of Bengal. So after that, I have compared the several El Nino and positive IOD years, and from this Hofmöller diagram, we can see that during the October, November, December of the El Nino years in the eastern Bay of Bengal, the second downwelling coastal Kelvin wave becomes weaker, and during the combined event of El Nino and positive IOD, it becomes completely absent. And during the La Nina and La Nina positive IOD years, it becomes moderately stronger. And during the La Nina and negative IOD years, it becomes strongest. So from this Hofmöller diagram, we have come to the conclusion that eddy activities weakens when the El Nino and positive IOD occurs, and eddy properties become stronger after the La Nina and negative IOD years. As a case study, I have shown the 1994, October, November, and December of 1994, and also October, November, December of 2019, that there is a clear upwelling instead of downwelling during this time period, and which has implication in the properties of eddies in the following season, because there is a time lag between the absence of coastal Kelvin waves, second downwelling coastal Kelvin waves, and the eddy properties. And the eddy properties reduced in the March, April, May of the following season. So coming back to the conclusion, I have studied the influence of climate variability on mesoscaletes in the Bay of Bengal. Mesoscaletes are important for as I have already mentioned that they contribute to atmospheric events and also biogeochemical properties. And from this study, we have two main findings that the eddy properties has been the anticyclonic eddies has been more impacted by both ENSO and IoT compared to cyclonic eddies. And also from this study, we can say that when the La Nina and negative IoT occurs, the eddy activity intensifies, and after the El Nino and positive IoT years, the eddy activity diminishes because the former event intensifies the second downhilling coastal Kelvin wave, whereas the second downhilling coastal Kelvin waves weakens or becomes completely absent during the later episodes. So these findings have implications for validating ocean climate interactions and also forecasting models. So these are the references. Thank you.
Thank you very much for the presentation. So are there any comments or questions from the audience? Please, Dr. Camila.
Thank you very much for the nice presentation.
Thank you, Professor.
From NYD, and I'm not very much familiar with this kind of study. So could you explain again, how do you detect eddies using the satellite data? So, and how did you validate results of your analysis? Two questions.
Okay, thank you for your question. I have detected mesoscale eddies with a Python library, which is called PyEddyTracker. And this library was developed based on the Charlton et al. 2011, which is known as CSS11. And by using this library, I have detected the mesoscale eddies from the sea level anomaly data. And the main mechanism here is that first the algorithm detects the center of the eddy. If the value of the sea level anomaly is lowest, then it is the cyclonic eddies, because cyclonic eddies, like they are concave shape. The lowest value is the center of the eddy, and this is the lowest value, and the anticyclonic eddies are concave up shape. So the highest maximum value of the sea level anomaly is the by doing this, we identify the center of the eddy, and after that, identifying the center of the eddy, we iterate over the center until we satisfy a set of criteria. For example, the shape error must be less than 55, and amplitude must be between 1 to 150 centimeter, which are defined in the Charlton's paper. And this library automatically detects the mesoscale eddies from the sea level anomaly data. And for validation, there from using the same algorithm, there is a data set in the AVISO website, archiving validation and interpretation of oceanographic data. So from that, there is a data set which is called Mesoscale Eddy Trajectory Atlas Product, also known as meta data set, and my identified eddies are consistent with the data set. So that's how I validated it. And also from other papers in the Bay of Bengal, my studies are consistent with theirs. the identification of the ADs.
Thank you very much.
Thank you, Professor.
Any other questions and comments? Okay, thank you very much, Mohima, Sultana, Mimi, and the presentation. Your presentation is very good. Thank you very much.
Thank you very much.
Yes, and then so I will move to the next presentation. Presenter is MD Mahmudul Hassan. Please start the presentation.
Thank you for giving me the opportunity. Can I share my slide? Okay. So, Assalamu alaikum and very good afternoon. And at first, I would like to convey my veneration and gratitude to our honorable chairs and distinguished scientists. It is a great opportunity for me to present my research topic before you. And today, my research topic is evaluating and mapping of atmospheric air quality in the coastal area of Bangladesh by using remote sensing and GIS techniques. My name is Mahmudul Hassan from Department of Environmental Science, Faculty of Science and Technology, Bangladesh University of Professionals, and my research is directly supervised by Dr. Asif Ahmed, Associate Professor of Department of Geography and Environment, University of Dhaka. And it is my presentation outlined. At first, I would like to detail the background of my research study and research objectives, data and methodology, result and discussion, conclusion, and the last part is questions and answer part. So, in the background of my study, I would say that the air pollution is one of the variety of man-made environmental problem. And air pollution may be defined as an atmospheric condition in which various substances are present at concentration high enough above their normal ambient levels to produce a measurable effect on people, animals, vegetation, or materials. Recently, air pollution has received priority among environmental issues in Asia, as well as in other parts of the world, and air quality is being polluted day by day very badly. A new source of air pollution is increasing hole in the ozone layer in the atmosphere above Antarctica, coupled with growing evidence of global ozone depletion. And air pollution has become a matter of great concern for us in recent years. Those who are living in cities in Asian countries have already realized how seriously air pollution has been poisoning life and degrading the environment. Thus, it is important to analyze the air quality in coastal area. It is to be mentioned that most of the air quality or air pollution research is held in Bangladesh in the air quality indexing method, while there has not been enough research to determine how air pollutants were distributed in the Bangladesh coastal regions. Therefore, this research attempted to evaluate the air quality in the coastal area of Bangladesh by remote sensing and GIS, along with spatial distribution of air pollutants. The benefit of utilizing satellite image that it can be demonstrated the condition of air across a wide region. This research summarizes several monitoring and analysis on ambient air quality level of nitrogen dioxide, sulfur dioxide, carbon monoxide, ozone, and particulate matter PM 2.5 in Bangladesh coastal regions. So here is my objectives of my research. Broad objectives will be the to evaluating and compare atmospheric air quality in the coastal area of Bangladesh by using remote sensing and GIS techniques. The specific objectives are to analyze the seasonal concentration data of sulfur dioxide, nitrogen dioxide, carbon monoxide, ozone, and particulate matter 2.5 in ambient air of the coastal areas of Bangladesh. To evaluate short and long-term trends of air quality in the coastal area, and to evaluate the particulate matter 2.5 in accordance with Bangladesh National Ambient Air Quality Standards, to visualize and mapping the spatial and temporal trends of the major concentrations of the air parameters through ArcGIS. So here is my study area, the coastal area of Bangladesh. I divided the coastal regions in two types. One is exposed coast and another is interior coast. The study will consider the whole coastal area of Bangladesh, an area of 46,271 km per square, is made up to 19 districts. This represents out of 31% of our country's overall area, where a total of 12 coastal districts are categorized as exposed coast, which are the Borgona, Bhola, Potuakhali, Pirojpur, Chittagong, Cox's Bazar, Feni, Lakshmipur, Noakhali, Bagherhat, Khulna, and Satkhira. And the remainder of 7 coastal districts are referred to as interior coast, which are the Borishal, Jhalokati, Chatpur, Gopalganj, Shorirpur, Jashore, and Noral districts. The exposed coast is limited to a range of 37 to 57 kilometers, whereas the coastal region extends from the beach of an area of 37 to 195 kilometers. Here the period of my record, where the nitrogen dioxide, sulfur dioxide, carbon monoxide, and ozone was studied in the period of 2018 to 2022, and the particulate matter 2.5 were studied in 1998 to 2019. So here is my research methodologies. The data is actually this secondary satellite data. Instrument and software, I have used the Sentinel's 5P topomy satellite, Google Earth Engine, ArcGIS 10.7, Microsoft Excel 2016, and the programming language I have used the Java, which JavaScript code editor was used in the Google Earth Engine to interpret the satellite data. Here are the flowchart of my methods. The data sets of nitrogen dioxide, sulfur dioxide, carbon monoxide, and ozone. These data were collected from the Sentinel's 5P topomy satellites. Then by using the Google Earth Engine and Java code framework, we downloaded the images of these satellites, Sentinel's 5P. Then we interpreted these images in ArcGIS by spatial and temporal filtering, and the outputs are it generates the air quality data tables, and we produces the map. And the trend analysis was by simple linear regressions test and Mann-Kendall test, and these two trend analysis is readily found the trend statistics of the specific air quality parameters. So this is the image of the Google Earth Engine. Most of us is familiar with this Google Earth Engine. So here are the detailed methodologies of my research. The Sentinel's 5P topomy datasets were used to find out the monthly variation from March 2018 to May 2022 over coastal area of Bangladesh. This study extensively used the Google Earth Engine platform in the analysis and data generation of various products, including from the topomy sensors on board the Sentinel's 5P satellite. And the analysis of all the variables was done using the JavaScript code editor, which is present in the Google Earth Engine developer framework, and the available offline data was used, and seasonal variation of 4 air quality indicators were studied to get a comprehensive view about emissions variations of all the significant trace gases in the atmosphere. So let's go to the result and discussion part. Here the particulate matter 2.5, the left image is showing the trend analysis of the particulate matter since 1998 to 2019, where we can found that the trend is increasing since 1998. That means the pollution or the concentration of the particulate 2.5 is increasing since the 1998 to present. And the right image is showing the comparison of particulate matter 2.5 annual average with the Bangladesh National Ambient Air Quality Standard, which is 15 microgram per meter cube per year, but the average particulate matter 2.5 was found about 56 microgram per meter cube in the whole coastal regions. This is a heat map analysis of the particulate 2.5 concentrations since 1998. It shows that you can see that in 1998 year, and the air quality of the coastal regions is much cleaner, but since the 2011 it is continuously increasing, drastically increasing the concentration of particulate matter 2.5. And if we see the right images, the comparison between the exposed coast and the interior coast. The exposed coast is much cleaner than the interior coast. This could be the reason of the interior coast is basically the adjacent to the most polluted city Dhaka and other developing cities. That could be the reason. And this is the distribution of particulate matter 2.5 concentrations in the coastal area of Bangladesh since 1998 to 2019. Here we can see the distribution of particulate matter. Here you can see the Chittagong and Cox's Bazar district is much cleaner than the Khulna, Jashir, Bagirhat regions. And this is the district concentration of particulate matter 2.5. And here we comes the seasonal variations. At first, I would like to say that the dry season I considered at December, January, February. These 3 months average is considered in this research, and the wet season. And the wet season is considered as the June, July, August. That means the monsoon season, and another is the post-monsoon season. Or winter season was considered as dry season. So in the dry season, we can see the 4 parameters of nitrogen dioxide, sulfur dioxide, and carbon monoxide and ozone. We can see that in the nitrogen dioxide, where the Chatpur, Shoritpur, in this region, this is the region, Chatpur, Shoritpur, and Lakhipur. Are showing the highest amount of nitrogen dioxide concentration in these regions, which was 221 micromole per meter square. Average nitrogen dioxide content of Chatpur was 110 micromole per meter square, which was the highest among the other 18 districts. That means the nitrogen dioxide concentration is very much high in the Chatpur district, which is adjacent to the most polluted city Dhaka. So the highest amount of nitrogen dioxide content was found in Chatpur, Shoritpur, and Lakhipur region in the dry season. Minimal nitrogen dioxide was concentrations observed over Cox's Bazar, Patuakhali, Pirojpur, Joshore, and Noral regions. And if we go to the sulfur dioxide in dry season, where we can see that the most sulfur dioxide pollution occurs in Bagirhat districts, Joshore districts, Noakhali districts, and Chattogram districts, their surroundings districts such as Satkhira, Khulna, etc. The majority of industries are clustered in these areas, which may contribute to air pollution in those areas. Furthermore, because of the presence of an industrial regions, Chattogram and Khulna districts experience sulfur dioxide pollution much. A comparison of maps made from the Sentinel's 5P products, yearly average of mosaic for tropospheric sulfur dioxide concentrations are revealed different trends in every year since the lockdown began, we can see that the year 2022 is much cleaner than the other areas. And if we, it is the dry season, and this is the wet season of sulfur dioxide, and also the nitrogen dioxide. And if we go to the carbon monoxide in dry season, we can see that the highest carbon monoxide column number density was observed over Khulna, Joshore, and Satkhira and Norail region. Average carbon monoxide density over mentioned cities exceeds 0.045 mole per meter square. Highest carbon monoxide concentration recorded on 2022 wet season June in Norail district. So in 2022 in June, the highest amount of carbon monoxide concentrations was found in Norail districts. So the highest amount of carbon monoxide content was found in Khulna, Joshore, and Norail regions, and these regions. And the rest territory was polluted with background carbon monoxide of about 0.044 mole per meter square, and minimal carbon monoxide concentration observed over Chattogram and Coxbazar region. And if we come to the ozone, this is the dry season of the carbon monoxide, and this is the wet season of the carbon monoxide region. And if we come to the ozone concentrations in the coastal area of Bangladesh, we can find the highest ozone concentration was observed over Khulna, Joshore, Satkhira, and Norail districts. It is also, so we can say that the Khulna, Joshore, Satkhira, and Norail districts are polluted much in the concentrations of sulfur dioxide, carbon monoxide, and also the ozone. And so,
Mr. Hassan, could you please finish within 2 minutes?
Okay, sure. So, this is the seasonal heat map analysis of nitrogen dioxide, sulfur dioxide, carbon monoxide, and ozone concentration. This is the seasonal trend analysis of the 4 pollutants in the coastal area of Bangladesh, where we can see only in the dry season, the Bagirhat and the Jhalakati districts are showing decreasing trend, and all of the parameters are showing the increasing trends in both dry season and wet season. That means the pollution is increasing since 1998 to present and 2018 to present. So here are the comparison of between exposed coast and interior coast, where we can find the interior coast is much polluted than the exposed coast, and the dry season is much polluted or highly concentrated than the wet season. So if I conclude my research, the particulate matter 2.5 was exceeded Bangladesh National Ambient Air Quality Standards value in every year since 1998 all over the coastal districts, with an average value of 56 microgram per meter cube. The interior coast region was polluted than the exposed coastal region. High concentration was found in dry season. Then the wet season, the year 2021 found much cleaner than the other study year due to the COVID-19 lockdown all over the Bangladesh. And the trends of the maximum pollutants are increasing means that the pollution is increasing all over the coastal area of Bangladesh. Thank you. That's all from my side. If you have any questions, please share. Thank you.
Thank you very much for the presentation. So any other, any questions or comments to this presentation from the audience?
Hello?
Yes.
Yeah, I'd like to compliment for a very exhaustive study. I just wanted to check up whether satellite data has been validated with the ground truthing. Any surface observations of the air quality?
Sorry, surface observation was not done yet, and we are thinking to validate the satellite data with the ground concentrations. Thank you.
Okay, and did you compare the northern parts of Bangladesh? Why you confine it to the coastal region alone when the source of pollution is the northern parts or the central part of Bangladesh? So why did you confine? The motivation of the study was to confine.
Okay. At first, I would say that the basis my supervisor was Dr. Asif Ahmed. His expertise on the coastal regions, and he suggested that there was no study regarding the air quality or air pollution standards in the coastal areas. So you should go to those areas, and we have a plan to compare those these studies with the northern part and also the other districts like or divisions like Sylhet, Mymensingh, Dhaka, and Prachi and Rangpur as well as. Thank you for your questions, sir.
Welcome. Thank you, Dr. Hassan.
So time is up. So we will move to the next presentation. The presentation is by Fariha Tabasam.
Hello, sir. Assalamu alaikum. May I start my presentation? Can you hear me clearly?
Yeah, yes, please.
Yes.
Okay. Okay, can you see my presentation?
Yes, perfect.
Okay. Hello, everyone. Good morning. My name is Fariha Tabasu. I am a former research fellow of Bangladesh Meteorological Department until last month, actually, under the project BWCSRP. And my project's presentation was supervised by Dr. Muhammad Abul Kalam Mollik, sir, who is a meteorologist of Bangladesh Meteorological Department. And my presentation topic today is the simulation of thunderstorm and its characteristics over Dhaka, Bangladesh using WRF ARW model. This is the outline of my presentation today. I will be introducing, then I'll be talking about chosen cumulus physics options, then experimental setup, then results and discussion. Finally, I'll be concluding. So thunderstorms, it's a naturally occurring phenomena produced by vigorous convective activity. Thunderstorm is a storm. It contains lightning and thunder, of course, and it may be associated with rainfall, gusting wind, hail, etc. And because it contains lightning and thunder, it sometimes becomes very dangerous to mankind and also to livestock and property as well. Typically, most thunderstorms occur over Bangladesh in the pre-monsoon season and the monsoon season. So people here are usually very prepared for it at that time. But with the change of climate, it is yet to be determined how this distribution will end up. So our focus is to increase the lead time of prediction of these storms. So to increase the lead time, I used the WRF ARW model. In the WRF ARW model, there are various physics options available, like the microphysics, the cumulus physics, PBL physics, radiation law physics, etc. Each of these physics options has lots of schemes. So in this first step, I'm going to be talking about the sensitivity test I did on cumulus physics options. And I'll just skip to the findings mainly because of shortage of time. So I found that the cumulus physics options number 1, which is the Kane-Fritsch eta scheme, had the least bit of error and the performance is, of course, the highest. So with this finding, I moved on to a thunderstorm case study. This thunderstorm event that I studied was occurred over Dhaka, Bangladesh on the 1st of May, 2016. The speed of the wind at 10-meter height was 107 km per hour. The experimental setup, this is the experimental setup that I did. The WRF version I used was 4.3.3 ARW model. I used it in a single domain at 9 km resolution. I started, the start time was 00 UTC of 30th of April, 2016. And the runtime was 48 hours. So moving on to the results and discussion part, firstly, I will be talking about the analysis of MSLP, which is the mean sea level pressure. It is development of the low pressure area is one of the most important part in the prediction of thunderstorm, in the occurrence of thunderstorms. So this is the model predicted figure that I compiled. This one is 1100 UTC, 1200 UTC, 1300 UTC, 1400, 1500, 1600. So the 1400 UTC, this part is mainly the time of the thunderstorm happening, and the previous three is the previous ones, and the next two are the next two ones. From this analysis, we can see a trough of westerly low, which is a supportive condition of thunderstorm. It's found near Bihar, India, before the thunderstorm occur, and it extends up to the eastern part of Bangladesh. Simultaneously, a high pressure area lies over the Bay of Bengal. So what is going to happen is that this high pressure zone, from this high pressure zone, wind should flow through the low pressure areas. We will see that in the wind pattern analysis, of course. And after the thunderstorm, the pressure gradually rises. From the computation analysis, we can see the model predicted data follows the pattern of the observed data pretty well, and with, of course, some error. Wind analysis. So the conjugation of wind from the two different direction forces the air to rise, which is very important for the formation of thunderstorms. During thunderstorm, a strong wind blows over the event area, which sometimes become vigorous and devastating. As we have mentioned before, the wind here was 107 km per hour, which is a very strong wind. So this can be a very devastating factor. From the pattern analysis here, we can see that southwesterly wind is flowing from the Bay of Bengal towards the country, carrying high amount of moisture. Also, northwesterly wind carrying dry air, because this is a dry area. Carrying dry air is flowing inside the country as well. This is the 850 HPA level, and the wind speed here varies from 4 meters per second to 16 meters per second. Next, we move on to relative humidity. The relative humidity is a very important factor. I would say it would be the most important factor, actually. The separating line of dry and hot air and warm and moisture is called the dry line. The conjugation of these two types of air is responsible for the formation of thunderstorm over the right side of the vicinity of this dry line. Here I can see that the dry line is clearly visible. So this is the part where the RH is very low, below 60, below 40, 50, 50, 40 even. And the right side of the dry line is very high moisture. From this, we can see that Dhaka city, here is the Dhaka city. If I can, I could have marked here, I'm sorry. But if I can see the Dhaka city, it lies in the right side of the vicinity of the dry line. Now, from the vertical cross section, we can see a high amount of moisture, almost this is 75% and up. High level of moisture extends up to 150 HPA level. This is the air level where temperature is very low, is well below freezing actually. So this is a very supportive condition for convective cloud formation and of course afterwards precipitation. From the computational analysis, we can see the model data follows the signature of the observed data and of course has some errors. From temperature analysis is also a very important parameter for the development of thunderstorm. When temperature of a particular region is very high, corresponding to a surrounding region, it creates a low pressure system in this region, and wind blows from the high pressure area towards this region, which produces a strong convection. This figure illustrates the temperature analysis of the thunderstorm event. Model simulated temperature in the west of Bangladesh is very high. over 36 degrees Celsius actually before the thunderstorm. Afterwards, the temperature is found to be decreased. Computational analysis is shown here. This model also captures the pattern pretty well, and of course has some errors. Moving on to vertical wind shear. Strong vertical wind shear is critical factor for development of severe thunderstorms, and we can see from this image that before the thunderstorm, that wind shear was very high, almost 35 and up meter per second. So this is a very supportive condition of thunderstorm as well. Moving on to vorticity. Updraft and downdraft is mainly indicated by positive and negative vorticity. When both of these are present simultaneously, it is supportive condition for instability of the system. So from the model simulated figure, we can see this is the 850 level of vorticity analysis. We can see that both these are the numbers of it. Both updraft and downdraft are present. Here in the 500 HPA levels, these are also simultaneously present. So we can say that the formation of deep convective cloud is a very well possibility. Moving on to MCAPE, modified convective available potential energy. This is a very what should I say? This represents the amount of buoyant energy available for vertical acceleration of a particle. Here, according to Ramsden Wilson, MCAPE value greater than 1500 joule per kg is required for the formation of supercell thunderstorms. And from the picture, we can see that the Cape over Dhaka at the time and before the time of the thunderstorm is almost over 2500. So 2500 to 3000 joule per kg is MCAPE is present, which is a very good indication of thunderstorm. Moving on to total index. Total index according to Miller, a value greater than 44 is indicator of thunderstorm. And in the picture here, we can see that Dhaka and surrounding areas has a TTI over 54. So this is a very high, and this is very high, and this is a very supportive condition for thunderstorm. Now let's move on to K index. K index has a long range of possibilities. So let us talk about 26 to 30 widely scattered thunderstorm, then 31 to 35 scattered thunderstorms. Over 35 is numerous thunderstorms in the country. From the model prediction, we can see that the K index all over Bangladesh is, of course, almost over 26, and in Dhaka especially, it's over 40. It's over 40 here before the thunderstorm occurs, even here, and after the thunderstorm, the K index doesn't rise or fall, but it kind of spreads around. Moving on to lifted index, it's a common measure of atmospheric instability. Negative values of Li indicates instability. The more the negative, the more unstable the air is. The following table, we can see in the following table, we can see the 0 to -3 region is marginally unstable. From -3 to -6 is moderately unstable. From -6 to -9 is very unstable, and below -9 is extremely unstable condition. And lifted index, for lifted index, I have depicted a SQT diagram. And from this SQT diagram, it can be seen that lifted index is -9, which from the table before, we can say is very unstable condition. So thunderstorm has been predicted very well. Finally, we come to rainfall prediction. So rainfall prediction is a bit, what should I say? It's a bit difficult in this model, even in the other numerical weather prediction models as well. The rainfall predicts the thunderstorms. The rainfall predicted here is, we can see in Dhaka is in what it is 2012 UTC, which is before the thunderstorm. And from the computation analysis, we can see the rainfall has been predicted, but it has a time error of almost 3 hours. And it's also said the rainfall to be almost 4 millimeter, but we observed rainfall was 10 millimeters. So it's a bit iffy, but overall, it at least indicates that the rainfall that may be occurring of rainfall. So that was all.
Okay, please finish.
Yeah, that was all. Even on 48 hours advance run, the model has predicted the thunderstorm even reasonably well. So we can say that the proper judgment of V10 can be done with this model. Thank you, everyone. If anyone has any questions, please. I think my time is probably up.
Thank you very much for the presentation. Please, any questions or comments to this presentation? Please, Kamira-san, please.
Thank you very much for the nice presentation. So, how do you think what factor is most important to evaluate simulation is good or not?
I'm sorry. Can you repeat that?
Which factor is most important?
Oh,
to
for me,
evaluate?
Most important is, I don't think they're most important anything. Mainly MSLP. The SLP, if there is a low pressure area developing, so there are chances are that a thunderstorm might be developing as well. And the thermodynamic characteristics also says a lot, but they are not always correct, but they are also important. But the prediction, what we actually need would be of the wind and of the rain. How much rain and how strong the wind would be. I think that would be.
And do you have any plan to utilize weather radar data to assimilate?
Yes. Yes, I have, but it would take some time to get there for me.
Okay, thank you.
Thank you.
Professor Terao, please ask the question.
Thank you very much. So very nice presentation. And so I'm very much interested in the dry line. It is developed in the monsoon season near Bangladesh.
Yes.
So how do you think the dry line is very critical or in the development of the northwest or not? And also sometimes come from some further northwest to Bangladesh.
Yes.
And that the northwest are formed before attaching to the dry line sometimes maybe. How do you think about this role?
The dry line, I think the dry line is very important because from the, if we can see where the dry line lies, we can predict where the thunderstorm might occur. So the dry line, the thunderstorms usually occur the right side of the vicinity of the dry line. So if we can see where the dry line is going, we can tell the people to who live the right side of the dry line to be careful that there is a dry line. There are possible convections happening on the dry line because the dry air and moisture is conjugating there. So I think the dry line is important at that role. Yeah, and the northwest part of Bangladesh usually carries the dry air because it's all land. There is no sea or there's no bay. And the right side has moisture in it because of the Bay of Bengal, of course, which is in the west, in the south direction of Bangladesh. So that's a very big reason for the dry line to be occurring over Bangladesh.
Understand. So sometimes the dry line may go just to the West Bengal region or something.
Yeah,
region. Yeah,
it does because the West Bengal also has Bay of Bengal attached in the east side of it.
Okay, so almost every time that the Northwest are developed in the
right side, yeah, almost everything, yeah.
Okay.
The right side of the right.
Is there any possibilities that some other small disturbance may come from the northeast of that northwest of that right? Is it possible?
I have to be more knowledgeable to answer that question actually, because I'm a research fellow. I'm not very experienced in that area. Sorry.
You have much experience. Very nice presentation. Thank you.
Thank you. Thank you. Thank you for your questions. Thank you.
Thank you very much.
Thank you very much. Fariha-san. So
yes. Thank you very much, everyone.
Please present the last presentation, Deepak-san.
Thank you. Sir, can I share my screen, sir?
Yeah. Yes, Deepak, please.
Is it visible, sir?
Okay.
Yes, perfect. Make it slideshow mode.
Okay, thank you. Good noon.
Yeah.
My greetings and honor to respective chair, co-chair, participants, and all who are connected with the conference. I am Deepak Dev, postgraduate student of Department of Oceanography, University of Chittagong. My presentation is on coastal vulnerability mapping and analysis over southeastern coast of Bangladesh. This research has done by me under the supervision of Mohammad Muslimuddin, Abu Sharif MD, Mohammad Kibriya, Mohan Kumar Das. So my motivation was, we know that Bangladesh is endowed with both natural resources, at the same time natural disaster. And world 15 most vulnerable regions is Bangladesh. And in the upcoming decades, the coastal region of Bangladesh will be extremely susceptible to climate and environmental changes due to its current poverty and intensity of hazard. And southeastern region and people of this part are substantially vulnerable to multiple hazards, which has made this region and people more vulnerable. So the significance of the study, if we can see that from global, national, and local scale, we know that the Bangladesh is a maritime country, which has 19 coastal districts, as we can see in the picture, and it has a large exclusive economic zone. We all know that, but it has very low topography and most dynamic country, and lies in the Ganges, Brahmaputra, and Meghna basin, and its final shape make is more vulnerable to coastal hazards or multi-hazards. So my objective was to identify the physical and social stressor and their strength that cause damage in coastal region of the southeastern zone, to identify the spatial variation of the coastal vulnerability of southeastern coastal region in terms of physical and social variables, and finally to identify the risks of multi-hazards in that zone. The study was done in the southeastern coastal region, which is approximately 377 kilometers long and extend from Mishorai Upazila along the Meghna estuary of Feni River to Teknaf Upazila. And this study encompasses the district of Chittagong and Coxbazar mainly, and cover 14 exposed upazilas, and endeavored a composite coastal vulnerability index, where we use 6 physical parameters and 4 social parameters, named coastal slope, coastal elevation, rate of sea level rise, rainfall, storm surge height, mean tidal range, and social parameter land use, land cover, population density, literacy rate. The study was extensively on secondary information and data and employed both qualitative and quantitative method. 2 equations used in the ArcGIS as square root of the product mean to calculate the PVI and SVI. First, we have calculated the physical vulnerability index and then social vulnerability index, and combining physical and social vulnerability index, we calculated the composite or combined coastal vulnerability index, ICVI. We can see the flowchart of the study. Now the result. First of all, the coastal elevation. We know that the low elevation coastal zone are most vulnerable, and high elevation is less vulnerable. So we used special 30-meter spatial resolution SRTM dam data for identifying the coastal vulnerability in the southeastern zone, and which I have found that the Sitakundo, Chittagong city, that means Kotwali, Hatajari, Ramu, and Ukhia, and Shondip and Adwara was between very low and medium vulnerability, whereas very high was Chokoria, Cox's Bazar, Shodor, Moheshkhali, and part of Teknaf. For coastal slope, it is a valuable component because it reflects the topographic gradient. We know that, and shoreline erosion mostly depend on the gradient of the slope. For gradient, we found that Anwara, Cox's Bazar, Chokoria, and Kutubdia, Ramu, that means the lower portion was very high vulnerable, and it was covered almost 30% of the southeastern coastal zone. Storm surge height. Tropical cyclone-induced storm surge highlights control of the coastal intensive inundation and flood. For this storm surge height vulnerability, we used IDW. All of it is done in ArcGIS 10.8. Here we have found that the Chittagong city, Anora, Hatajari was very high vulnerable, where from Bashkhali to Teknaf was vulnerable, high vulnerable. And it was covered the most of the area, 63% almost. Now the average annual rainfall, which is very important physical parameters. Previous presenter also include these parameters for their study. I have also included this. So rainfall and storm tides contribute to the flooding in the coastal zones. In my study, the Teknaf, that means the most lower part portion of the study area was very vulnerable, because here the rainfall is very high. We can see from that sometimes in 1991, 1994, 2008, and 2015, it was more than 400 millimeter. So it, in terms of rainfall vulnerability, we can say that the Ukhia and Teknaf, that means the lower part portion of the southeastern coastal zone, was most vulnerable. Then the rate of sea level rise, which is a present concern of all scientists. I have also included this in my study, and I have found that the Kutubdia, which is an island actually, that was very high vulnerable, but the other island that was the upper portion in the southeastern zone, the Shondip, was less vulnerable in terms of sea level rise. Mean tidal rains. In accordance with the CVI research and microtidal coastlines of the study area, this study assumes that the greater the tidal range, the lesser the susceptibility. Other studies have used the opposite things, but I have studies the greater the tidal range, the lesser the susceptibility. So in terms of mean tidal range, we can see that from Mishorai to Anwara, that means the upper portion was less vulnerable, where the Teknaf and some part of Ukhia was very vulnerable. Now the social vulnerable parameter, population density. As Chittagong city, it was a city area, and it's also a division. So it was very high, it has very high population density. And in terms of population density, it was very highly vulnerable to multiple hazard, whereas the Hatajari, Anora, Cox's Bazar, Shodor, and Bashkhali was also following the Chittagong city. Literacy rate. Generally, literacy rate is high in city area than rural area. So we can see that the Teknaf Upazila, which is more rural area there, and Kutubdia, Bashkhali, Moheshkhali, Ramu, Ukhia, that parts, the literacy rate was low, and where the literacy rate was low, there the susceptibility or vulnerabilities more. Land use land cover. For this land use land cover, I actually used the ISRI Global Land Cover 2020 data. However, I have found the built area, as I have said, that there is more, Chittagong city is a city area, so there is more built area, and so it is very vulnerable in terms of land use land cover. On the other hand, Ramu, Ukhia, Teknaf, there is so much water body, bare ground, trees or vegetation, so they are fallen under very low and low vulnerable areas. So if I have used the secondary data, I have tried to accuracy assessment of the land use land cover, where I have found 90% overall accuracy, which was good. Finally, I have calculated the physical vulnerability index in raster calculator of ArcGIS, and I have classified these groups into very low, low, moderate, high, and very high as before. And in terms of physical vulnerability index, finally, I have found Kutubdia, Moheshkhali, Cox's Bazar Shodor, Chokoria, some parts of Bashkhali, Ukhia, Ramu, and Teknaf was high to very high vulnerable. But in social vulnerability index, high vulnerability and very high vulnerability regions encompasses the most of the regions of the middle and lower part of the southeastern coastal region. Finally, the coastal vulnerability index, which was my focus. Combining the physical and coastal vulnerability index, I have found Bashkhali, Kutubdia, Chokoria, Moheshkhali, Cox's Bazar, Shodor, Ramu, and some parts of Ukhia was high to very high. We can see that extremely vulnerable. On the other hand, Hatajari, Mishorai, Sitakonda, Sondip, that means the upper portion, we can see that in the next slide, are less vulnerable, significantly less vulnerable. So the very high and high vulnerable areas cover approximately 10% and 16% respectively. As I said, we can see that the upper portion was green. That means they are safe in terms of vulnerability or multiple hazards. So middle portion and lower middle portion very vulnerable, and lower part of the study area moderate to high vulnerability, and uppermost portion this vulnerability is showing. So some discussion. We can see that the upper region of the southeastern coastal region of southern side are less vulnerable because average rainfall was low there, and several hilly areas was present in this region. We know that Chandranath Hill in Sitakundu region and Adinath in Moheshkhali. We have seen that the three islands, among them, the Kutubdia was very vulnerable, then following the Moheshkhali. And on the other hand, Sondip was safe in that term. It was less vulnerable. We can see that the Cox's Bazar, we all know that the most tourist attraction place, Cox's Bazar, which is under pressure of high-rise buildings and hotels and lots of tourists. So it is susceptible to coastal hazard, coastal erosion, and some other things. And we have also seen in other studies and previous studies that massive deforestation has occurred in Chokoria, which has caused high salinity intrusion, massive changes in land use, land cover, and severe stream farming has made Chokoria more vulnerable to physical variables. So my studies have found some similarities with previous studies, but we have some limitations as we had to use secondary data. So there was low resolution of satellite images and dam. And this study, especially for social vulnerability index, we have used some social parameters. That's why we have to use census data from 2011 as the last official census was before 2021. And I have put there some needs assessment and future direction. Actually, environmental research in Bangladesh has many lackings, physical variables as such as aerial photography has low resolution, and we have to create a library, separate data bank for tidal data as well as LUL, sea landform slope, elevation, shoreline, so that we can carry such like research. Besides physical and social variables, researcher can use, as I have used here, only physical and social variable. Researcher can use institutional, environmental, ecological, economical variable as well. Thank you.
Thank you very much for the presentation. Any comments or any questions for this presentation from audience?
Now floor is open for questions. So we'd like to request dear audience, if you have any questions, please.
Dr. Kamiera, please.
Okay, thank you very much for the good presentation. So could you explain again about what is the coastal vulnerability? Because how to say, definition is very, for me, definition is very, how to say, complicated to understand. And for example, your target region is in the coastal region. So in such case, how to say, storm surge or something most important for the region to assess the vulnerability of the region. So, but you utilize many data and analyzed very hard. But how to say? Anyway, could you explain about the coastal vulnerability again?
Okay, thank you, sir, for your question. Coastal vulnerability is the susceptibility or the strength, how a coastal region or exposed region can be affected by several hazards or physical stressors like rainfall, storm surge, wind speeds, how it can be affected, and in how much strength it can be affected by these factors, and what will be the future results of these regions or of this part if these physical stressors like cyclones have affected or fallen on these areas, which will be the response, because the different regions have different physical parameter, physical characteristics, geomorphological characteristics, biological characteristics, and their response is always different. And different parts have different responses for different hazards. So in my study, I have tried to show that which region will be more or most affected, and which region will be less affected by these physical stressors or multi-hazards like cyclones.
How to say, in such risk analysis, we consider three components. At first, hazard, and second one is vulnerability and exposures. So, but in your analysis, you employed some factors of social component. So these are, how to say, belonging in the exposure component.
Okay.
So, but Yeah,
Yes.
you utilize that data for the calculation of vulnerability. So I'm a bit confused. This one.
Okay, sir. Besides or along with physical parameter, I have used social parameters, some social parameters, because in some previous studies, most of the studies actually focused on physical parameters. But we in Bangladesh, or as a researcher, we think that this vulnerability is not only dependent on physical parameters, it has also social impact or social influence, because if population density is high, then there will be more damage, or there will be more affected area. And if and when I have said that literacy rate, if a literate person is more conscious about hazards than an illiterate person. So I have used, for this reason, I have used the social parameters along physical parameters to cover the overall CVI, as I have tried to develop a ICVI, that means Combined Composite Vulnerability Index.
Yeah, so at this moment, I don't have a good good suggestion, but yeah, anyway, yeah, your research is very nice, and
thank you, sir.
Maybe, yeah, how to say, in the summary part of your study is very important. What is your message of your research is most important to utilize your own results? Yeah. Okay. Yeah. Anyway, thank you very much for the good answers to me, to my question.
Thank you, sir. Thank you for your questions and suggestions. Actually, I am in the very beginning stage of research. I'm just completed my graduation, and I have tried, and I will also try to do something better in this region of the research. Thank you very much.
Thank you very much.
Next question is Terao-san.
Yeah, thank you very much. And you suggested that the region, Chakoria region, has some big vulnerability by the natural change. So I heard about some intrusion of the saline water in the tube wells, and their daily usage water, and it interacts with the people's health there. So the model include this type of somewhat longer factor, the long time factor to that people through that the health conditions.
Thank you, sir. It was my also observation, because I was also tried to include a parameter like soil salinity or soil permeability, because as I am saying about the soil salinity intrusion, so I have tried for secondary data something like that, soil permeability or soil salinity. And we have found that several studies have done on soil salinity in western part of the Bangladesh, especially in the western part, but eastern part I have found less. And due to the limitations of secondary data, especially on soil permeability and soil salinity, I have failed to include this parameter. And if I could include this parameter, then I would also explain the present condition and the previous condition of the people of this area, because this area was very rich, because this area was called the second Sundarban, that means the mangrove forest. But due to the deforestation, especially the hatchery has spread out there enormously. So the spread of hatchery has damaged this mangrove forest. And as we know that mangrove forest is very responsible, is very important for our ecosystem. So due to less mangrove forest and deforestation and other things, this chocoria has become more vulnerable, and I have also found in my studies, but not in terms of soil salinity, in terms of other physical parameters. But I have tried, as a newcomer or beginner, I have tried to include the soil permeability parameters actually, but I have failed.
I see. Interesting. So maybe we can utilize your results for the planning for the development in these regions. So thank you very much for your.
Thank you. Thank you.
Thank you.
Thank you very much for the presentation. So, we have to summarize today's session. We have 5 minutes to summarize up. Noami-san, do you have any? You have?
Yes. Okay. So I should say some words, then you can also include whatever you like. Thank you, sir, for the opportunity. Really, it is an interesting and very informative sessions, and which cover nature-based climate solutions. This is session 1. I am very much grateful to the chair who conduct the sessions, and I give my support, and especially my gratitude to the organizer, especially Professor Tawhida Madam and Dr. Fatima and Shourab, and of course, University of Dhaka. They continuously arranging these kinds of important initiative. And in these sessions, there are 7 paper. Out of 7, there are 6 paper presented, so 86% is achieved. So that is a very tremendous achievement. All the papers and all the studies are very much informative, and it is praised by the audience, participants, and also there are some comments, suggestions, which really give some positive feedback to the writer, so they can incorporate all those things in their study, and it would be a good manuscript, and they can submit it in a very good journal in future. So in a nutshell, very first paper, Hidikyo Kanumera, in his satellite-based comparison, and the study is very significant, especially the region is very important, Magna Basin, and it covers the conjugate of other 2-3 countries together, and especially northeastern part of Bangladesh and also the Indian part. And another thing, he very much precisely incorporate the radar things, that is state of the art. If it really complete a good study, it will support the community tremendously, especially the water related any kinds of issues and conflict storms. Second part, second lecture, it's covered the agromet advisory services and citizen science knowledge can be incorporated, and it really gives community, and community feedback is important. So these 2 combination is there. Unfortunately, third paper is missing. Obviously, he cannot attend. Mohima's study is very significant in the matters of mesoscaletes from the ocean, and it is very praised by the Dr. Somaswar Das sir. He mentioned in the chat box, and I think Mohima can take good initiative to publish his study in a very good journal, and he also used the various state-of-the-art tools, Python ED tracker. I think he would get some good results from that. And in the 5th one, atmospheric quality, air quality, that is very important study, especially focused on the coastal part. But the important thing missing in the coastal observation part, it is already noted by Professor Yarbashman Tyagi sir. I hope the author will incorporate those things in their study, because ground truthing is important. Maybe the limitation is that there is not that much any observation. I am also not sure who is the mandate to take regular air quality observations in the many regions of Bangladesh, especially coastal boundaries. So if it is the gap, so I think government should take good initiative to install air quality monitoring observation throughout the country. So really, it is not in Bangladesh. So I think through the study, it can be a very good suggestions. And WRFN, yeah, WS study, it is very much important, though there is a lots of scope to further improvement by comparing their results with the observations, because lots of upper air sounding observation is available and ground truthing is available. So it can be a good study then. And also Hideki Kanemaru suggested data assimilation procedure need to be incorporated. I think that will be very much important to give the community in a good feedback. The community demanded impact-based forecasting. Research is all right, but need to give community some message. So it will be useful for the community. Finally, Coastal Vulnerability Index. As a fresh graduate, he has taken really very inspiring initiative, and the results is based on the lots of data analysis. So I hope all the author will take the very good initiative to publish the manuscript in a very good journal. I am also the part of the study. So I will inspire Divos to take proper initiative to publish the results in a very good journal. And in a nutshell, all the comment suggestion is very helpful for the all. And I would like to request Honorable Chair to say a few words or anything for the audience as well as the participant. Thank you, sir, for the opportunity. Thank you.
Thank you very much. So we would like to close this session. Thank you very much for the all the participants and the Professor Towahida and Professor Dr. Fatima Akhtar for this session. Thank you very much. I will close the session. Thank you.
Thank you all. It is very timely. Shubho, please.
Yeah. Yes, sir. It's within time. And thank you for nicely monitoring and moderating the session. So I'd like to take this stage to thank both Professor Dr. Taichi Hayashi and also Dr. Mohan Kumar Das sir for nicely conducting the session, and also all the participants, especially the students, because it's not every day that you get an opportunity to present in international conferences. So huge congratulations to them for being appreciative about the participation. And also I'd like to thank Dr. Hideki Kamimera, who was actually the session speaker at the beginning of the session, and also Dr. Mahbub Jahan Khan, because he presented a nice talk about the endemic knowledge of farmers about precipitation and weather phenomena. So with that note, I leave it like that, and we will have our next session starting from just about 20 or so minutes. So
Shubho, just a minute. Yeah. Shubho,
yes, ma'am.
Can I say, yeah?
Yes, sure.
I can see Professor Tyagi and Professor, Terao Kamimera-san and Professor Das as well. So it's really nice to see you all here. And thank you all for joining us with this session and for your contribution, and especially Professor Hayashi and Dr. Mohan Kumar for nicely conducting this session. Thank you all. See you for next session. Thank you. Bye.
Could we request for a group photo? So it will be a good memory for all of us.
Oh, sure. Please take a snap. Okay.
Yeah. So if possible, everyone are requested to switch on their video. I think we can take a group photo then.
Just wait for 1 minute, Shubha. I'm coming at conference room. Please wait for me.
So, hi, sir. It is very nice to see you after a long time. Hope you
yes,
are in a good health and if possible, sir, visit Bangladesh. We miss your kind presence in Bangladesh also.
Yes.
Good afternoon. Good afternoon, Professor Hayashi.
Good
Dr.
afternoon,
here.
Tiagi-san. I'm so happy to meet you. So
Yeah. Same here. Same here. How are you keeping?
Fortunately, so I will visit India also next year.
Okay.
So, madam, are you ready, please? So you can take the snap. Thank you, sir. It is taken.
Okay,
Thank
I think
you.
it's taken. Okay, thank you all.
Thank you.
Manansheb, how are you?
Thank you.
Hello, Karausen.
Thank you, dear. So, not seeing long.
Yeah.
Very soon. Maybe this February month. Thank you very much.
Dr. Tyagi sir, Mr. Jahan has replied that that short-term validation not yet undertaken. Maybe that is a very good suggestion for him. He will take and consider.
Yeah, we'll follow it up. Follow it.
এটা পড়েছিল না শুভ তোমরা লাঞ্চ করে নাও হ্যাঁ আপনাদের করে দিলাম
ইয়ে ভালো মতো মিশানো হয় ইয়ে থাকাতে ব্যাকগ্রাউন্ড থাকাতে
Okay, bye everyone. See you in the next session. Bye.
Okay, see you soon.
Thank you, madam.
Thank you.
এটা কি তরুতর আবার মোহন নাকি